So hello guys, today's discussion topic is the hyperconjugations effect. For the hyperconjugation effect, it is the orbital interaction between the pi system adjacent to the sigma bond of the substituent in the group. Okay, means what? It is the interaction between the pi and the sigma bond adjacent to the alpha carbon atom. There is the double bond adjacent to that. There is a alpha carbon atom, and at the hydrogens are attached to this carbon atoms, that is the sp3 carbon ch3 tetrahedral, where the hyperconjugation is happen is like this. जब ये बॉन्ड कार्बन एंड हाइड्रोजन का बॉन्ड इधर शिफ्ट हो जाएगा तो this pi bond will shifted towards this carbon atom, so that the hyperconjugation of this hydrogen first will happen like this. Okay, in such a way 3 hydrogen can be replaced in the same manner. Okay, so this is nothing but the conversion of sp3 to sp3 to sp2 carbon atoms. This is formed by hyperconjugation effect. Hyperconjugation in alkenes is like that. For the examples of hyperconjugation of alkene, we have taken the two compounds where this form a 9 alpha hydrogen atom, this form 12 alpha hydrogen atom. How they form, let us know. This is nothing means this is the carbon atom where 3 hydrogen are attached to every carbon atom, that is hydrogens. Okay, and this is the alpha carbon. For this is alpha carbon, this is alpha, and this one also alpha carbon atom, and hydrogen attached to this alpha carbon atom are how much? That is the 3, that is 9 alpha hydrogen, which is adjacent to the sp2 carbon of the alkene. So there is a 9 alpha hydrogen, and the hyperconjugation happens in like this. The forming of in this compound, there is alpha carbon, there is the alpha position, and this is the alpha carbon, this is also alpha carbon, alpha carbon, and this hydrogen are attached to it, that is hydrogen. How much hydrogens are there? 3 and 3, that is 12 hydrogens are attached to this alkene system. So there is 9 alpha hydrogen atom, and more number of alpha hydrogen atoms means the more stability of that compound and the more hyperconjugation effect. So in compound first and compound second, the more stable compound will be second is greater than first. Now the condition for hyperconjugation is there must be alpha CH group or a lone pair of atom adjacent to sp2 hybrid carbon, or atom like nitrogen, oxygen, or alkyl group. Means the heteroatom, if it is attached to this alkyne system, so there should be formation of sp2 carbon after the hyperconjugation effect. So example is here the nitromethane we have taken, in which the CH3 group, the hydrogen carbon hydrogen bond will shift like this, so that the nitrogen and oxygen double bond will shift like this, and the hyperconjugation of this hydrogen happens, and the formation of this compound is formed. So this is the hyperconjugation effect in hydroatoms. Okay, why only we are using hydrogen atom, or not, why not deuterium and tritium? Because the bond strength of the hydrogen atom is very weak, so it is easy to break the carbon and hydrogen bonds, so it is prefer the hyperconjugation for hydrogen atom. In this compound hyperconjugation in the carbocation, what happened here? We have taken the 2 carbocations groups like this, in which हमें क्या करना है कि देखना है इसमें कितने अल्फा हाइड्रोजन एटम्स मिल सकते हैं. तो इसमें कितने मिलेंगे आफ्टर द ब्रेकिंग ऑफ दिस ईच हर एक कार्बन हाइड्रोजन बॉन्ड ब्रेक करेगा तो हमें कितना अल्फा हाइड्रोजन मिलेगा, उसके डिपेंड में होता है कि हाइपर कॉन्जुगेटेड स्ट्रक्चर कितनी बनेगी, एंड दैट द स्टेबिलिटी. सो हाउ मच हियर द कार्बोकैटाइन, आफ्टर कार्बोकैटाइन के एडजेसेंट में है अल्फा कार्बन, इसमें ये भी है अल्फा कार्बन, इसमें है 3 हाइड्रोजन, इसमें भी 3. सो हाउ मच 6 अल्फा हाइड्रोजन आर प्रेजेंट हियर, एंड इन दिस केस ऑल्सो there is 3 alpha carbon group are present. So in this CH3 there are 9 alpha hydrogen are present, so that the stability of the second compound will be greater than first, because it has 9 alpha hydrogen, means the more stability. In this compound also, here the hyperconjugation is happen in the acidic medium, acid like H2SO4. So what happen, the lone pair of electron will takes the hydrogen atom, and the removal of water will takes place. So after the removal of hydrogen atom, the compound will like this, the carbocation will here. So that similarly here also water remove हो जाएगा, यहाँ पे carbocation CH3, here also the removal of hydrogen and water molecules. So that here now this is the carbocation, adjacent to that is the alpha position. This is also alpha position, and this carbon also in alpha position. So how many electron hydrogen atom are present in this is nothing, ये तो CH3 है, this is CH3. So 1 2 and this is 3, means the 3 alpha hydrogen are present here. In this case, this is alpha position, this is also alpha position, there is one hydrogen and there is, and this is the hydrogen atom. So this is also alpha carbon atom. So this three hydrogen, 3 plus 2 5 6 and 7, there are 7 alpha hydrogen atom are present in this molecule. Similarly, in this case, this is also CH3, adjacent to that this is the alpha carbon, and there is only one hydrogen is present, so there is only one alpha hydrogen atom. So this is hyperconjugation effect in acidic medium. So the hyperconjugation effect, we can conclude the more hyperconjugated structure will be more stable, and the hyperconjugation effect has very much importance in the molecules which is happen in carbocation, also alkenes also, and radicals also, as well as in the heteroatoms. The hyperconjugation is happen. So if you like my video, please like and subscribe.